Saxon Algebra 2. Lesson 120. I know it seems like that should be the last lesson for the year, but remember we've adjusted the flow here a little bit. We covered 117 and 119 together. We covered 118, which included parts of 122, but we're not doing any homework from 122. So now, for the penultimate lesson in Algebra 2, we're going to do 120, and then I'll be back tomorrow with lesson 121. That will be our final it'll be 120 lessons. We just got the numbering a little crazy here in the last week. All right, so age word problems. What are those? They're a classic style of word problem. I've seen them pop up on standardized tests, although I must say these are the most challenging form that I've ever seen. But we're going to study them, and we'll come back to them a little bit next year, but this is really as hard as they get. The key to these problems is setting up the variables the right way. So we'll deal with that trick in a minute. Let me read you the problem so you get an idea. A man is 13 times as old as his son. In 10 years, he will be 3 times as old as his son will be. How old are they now? Oh, okay. Well, what we need to do is we need to make a chart to organize this data. You know I love a good chart. And John makes a good chart too, but you know what? He doesn't use lines because it's too hard to print. So his charts lack the same pizzazz that ours do, if you want my honest opinion. And I know you do. Okay, so here's the man, and here's his son. I'm not gonna call him son because I don't like to use S as a variable, so I'm gonna call him Junior. I'm down with a J. Here are their ages now. We're gonna use a little subscript just to help us keep it all straight. Not necessary, not mandatory, but fun. The man now and Junior now. And then the problem also refers to what their ages will be 10 years from now. So I'm gonna write in 10 years here. What will the man's age be in 10 years? Well, I don't want a new variable. I want to take my old variable and just put a change to it, right? Because we know that for every variable you have, you need an equation. So if you have 3 variables, you need 3 equations. If you have 2 variables, you need 2 equations. So we want to keep the number of variables down so that it keeps our problem simpler. So that's why we use this little trick. Okay, and that's the secret to these problems, is learning to make their age now and then adjust it as however the problem needs us to be. It says that the man is 13 times as old as his son. That implies now. So again, let's write an inequality. The man now is older than his son. Well, that makes sense, doesn't it? And how much older is he? 13 times older. So in order to make this balance, to write an equation, I need to give this smaller number the power of being multiplied by 13. Now they're equal. I don't love the way that that looks, so I'm just going to make a little note to myself over here. Mn equals 13Jn. I like that better. That looks nicer to me. It's the same as this, but I just want to do that. All right, now in 10 years, he will be 3 times as old as his son will be. Okay, so let's now use their variables for in 10 years. The man in 10 years will still be older than his son, his junior, in 10 years. Look, I left room for some more multiplying. He'll be 3 times as old as his son. So to get this to balance, we're going to multiply this side by 3, right? The smaller side is what gets multiplied. We hear man is 3 times older and we want to multiply man times 3. No, he's already older. We don't need to increase his numbers more. We need to give this other guy the power of the 3 so that we can say that they're equal. Okay, beautiful. Now I can see that we're going to be able to do some substituting, aren't we? So what I'm going to do is I'm going to do 2 things at once because I'm crazy like that. We're going to substitute this equation in here. I'm going to change that to 13jn. And then we're going to distribute here all at the same time. Okay, so that's distributing and substituting. We can handle it, right? Okay, so the left side becomes 13 times Junior's age now plus 10, right? That's this piece, equals 3 times Junior's age now plus 30. Are you feeling it? I'm feeling it. Okay, how do we want to swim things? This is the bigger JN. Let's bring this one over so we'll stay positive, and then we'll bring the 10 over that way. Swimming those fishies. It was a long time ago you learned to swim fish, but you know what? We're still doing it. Cancels, cancels. 10jn equals 20. Oh, John, thank you. So Junior's age now is 2. Aw, he's a little toddler. And then we need to find the man's age now. It's 13 times Junior's age, so that's 26. Yay. And then just for fun, we can see that in 10 years, Junior will be 10 years older. He'll be 12, and he will be 36. And sure enough, John told us that in 10 years, the man would be 3 times older, and 3 times 12 is 36. So it all works out. We didn't need to do this. I was just having fun. This is the right answer. John wants to know how old are they now. Yay, we did it. Okay, there's a total of 3 of these problems. Oh, I didn't even write this down. This is example 120.1. 120.2. These other 2 examples are the same idea, but they're just a little bit more complicated. Story of our lives, right? 5 years ago, Brenda was 4/5 as old as Leighton. Okay, so we're having past numbers and we're having fractions. That's annoying. 10 years from now, she will be 7/8 as old as Leighton. How old is each now? Oh my gosh, that's annoying. Okay, what we're gonna do is we're gonna make another chart. But this time, we're gonna need 5 years ago, now, and 10 years from now. We have more time frames. So I'll show you how I figured that out. Let me just draw a row for each person. This is Brenda. This is Leighton. Kind of like Clayton without the C. Okay, now I like to keep these in chronological order. So this is 5 years ago. This is now, and this is in 10 years. There are 3 time frames, not just 2 like last time. Now always gets the basic variables. 5 years ago, okay, it's pretty easy to see that's going to be -5, right? Her age now, -5. Same for Leighton. Oops, -5, not an equal sign. And then +10 for their ages in 10 years. This isn't hard to set these up, but by writing it out, it will keep your head straight when now we're going to throw all these crazy fractions and stuff into the mix. All right. 5 years ago, Brenda was 4/5 as old as Leighton. Okay, Brenda, 5 years ago, is Bn -5. Leighton, 5 years ago, is Ln -5. Who's older? She was 4/5 as old as Leighton. That means Brenda is younger. Okay? Now, how do we decide who needs to get multiplied by 4/5? This is terribly confusing if you just look at the numbers. Pull back a layer and think about what's happening. We're being told that her age is 4/5 that of Leighton. 4/5 is less. It's smaller than 1, right? So it makes a number smaller. So that means she is the smaller. That means if you're going to be multiplying something by 4/5, that's going to make it smaller, right? So we want to multiply his age by 4/5 in order to make them equal. Because multiplying by 4/5 is less than 1. So it's going to drag this number down and will make them equal because she was smaller to begin with. We sure don't want to multiply her by 4/5 because that will make her smaller still. So this is the equation. Oh, it was hard, wasn't it? 10 years from now, she will be 7/8 as old as Leighton. Okay, so now we're going to write the plus 10. 10 years from now, Leighton, 10 years from now. I'm leaving lots of space between them because I don't know who's going to need the fraction this time. 10 years from now, she will be 7/8 as old as him. Okay, so she's still going to be younger than him, which I suppose makes sense because once we're younger than someone, we're always going to be younger, right? We never get not younger than a person who's older than us. So now it's 7/8. That's still a fraction less than 1. He's still greater. So now I'm still going to multiply him by this fraction because this is going to make his number smaller because this number is less than 1. So that's how I balance them. These fractions are tricky to think about. All right, now we have two equations. We're solving them as a system. I didn't overtly say that last time. Let me fix it. Go back and do it to yours too. It's a system of equations, obvi, right? So at least on the first set, I like to put that bracket. All right, now, what are we going to do to simplify these? Because these are a hot mess. Well, remember that whenever we have fractions in an equation, we can eliminate them by multiplying both sides by the denominator, or the common denominator. So what I'm going to do is I'm going to multiply both sides by 5. Here, on this side, I'm going to write it like that. And here, I'm going to write it, I'll do it the same way, like this. These cancel. These don't. Now I have to just, well, I'll write it first as this. It's 5 times bn minus 5 quantity equals 4 times ln minus 5 quantity. Cool? Okay. Now let's do the same thing to fix up this one. This has a denominator of 8, so I need to multiply both of these by 8. Put the 8 on this side. I'm just going with wherever I have room. There's no reason why I put it after or before. It's just where I had space. Okay, now these cancel, and I'm going to have 8 times bn plus 10 quantity equals 7 times ln plus 10 quantity. It's my new system. Oh, what happened there? Okay, ready? Let's distribute. We have 4 distributions, don't we? All right. I'm going to the top of my next page. So here's what we've got. 25 5bn minus 25 equals 4ln minus 20. That looks better, doesn't it? And then the bottom row, 8bn plus 10 equals 7ln plus 70. There's my new system. Now, I see coefficients in front of all 4 of the variables. That tells me that substitution is a bad idea. So I think I'm going to need to eliminate. But before I can really do that properly, I have to get a setup for elimination. When we want to eliminate, I'm sure you've noticed this, it works best if we have x plus y equals number. Okay, that's the way we like to set up our equations when we're preparing to eliminate. These are scrambled. I've got one variable on each side and I've got plain numbers on both sides. So we're gonna rearrange. We're gonna bring the ln's over to this side and we're gonna kick the numbers over to that side. So this first one will become 5bn minus 4ln, change sides, change signs. I'll be adding 25, so this will end up equaling 5, won't it? Because this will be plus 25 and minus 20, that'll be 5. Okay, so I'm getting them into this format. Now, this one I have to do the same thing. 8bn, and this will be minus 7 ln equals, here I'm subtracting 10, so that'll be 60. I'm just double checking my numbers. This is wrong. It says minus 10. How could that be minus 10? My brain's feeling... Oh, I see what the problem is right here. This isn't 10, this is 80. My mistake. There's the problem. When I distributed, see right here, 8 times 10. I didn't do 8 times 10, I just copied the 10. You were probably losing your mind, screaming at me. This is 80, so when I subtract 80 from 70, there's the minus 10 I wanted. All right. Oh, I feel much better now. Okay, beautiful. Now we figure out, we need to do something to eliminate these. What the heck are we gonna do? I would like to multiply, not this column, I would like to multiply this column. I want to turn this into a positive 28 and this a negative 28. So I'm going to multiply this one by negative 7. And I'm going to multiply this one by positive 4. That will get me positive 28 and negative 28. And then we'll see what happens after that. All right, let's see if I make more mistakes. Minus 35bn plus 28ln equals minus 35. And then down here, 32bn minus 28ln equals minus 40. We add these. This cancels, and we get minus 3bn equals minus 75. Thank you, John. So, Brenda's age now is 25. And then we just need to go back and find somewhere an age for Layton. I keep wanting to say Clayton, and that's not right. Let's look at their original. Oh, their original equations have, the original equations have fractions. No, thank you. These I would have to redistribute. No, thank you. That means maybe this one. This is cleaned up, right? So I'm going to use this one. 5bn minus 4ln equals 5. 5 times 25. And what I'm going to do is I'm going to switch sides on these. Minus 5 equals positive 4ln. That will save me algebra drama in just a minute because I'm turning this into a number. This is 125. So 125 minus 5 is 120 equals 4ln. And then I divide both sides by 4. And I get that Leighton's age now equals 30. Yay! That's the right answer. John asked us to find their ages now. But sometimes he might ask us, oh, what will their age be in 20 years? Well, we could go back here and add 20 to it, whatever, right? Once we calculate their ages, quote unquote, now, we have unlocked the riddles, and then we can look at the particular answer John wants and reshape it if we need to. But getting these answers is usually where he leaves us. Okay, one more. Example 120.3. 30 years ago, Barbie was 1 year older than twice Mary's age then. Oh boy. 20 years ago, Mary was 4/5 as old as Barbie was then. Do you have a headache yet? I do. We've got Barbie and Mary. We've got two different scenarios, 30 years ago and 20 years ago. Let's set up our chart. Barbie and Mary, and there's 3 age frames. That we have to look at. So I'm going to make 3 columns here. One is 30 years ago. One is 20 years ago. And this one, ago, not age. And this one is now. I like to keep them in sequential order, right? Put the farthest away time frame. And then this one, they're all in the past, so we just build up to now. That helps my brain stay in logic mode. So this is Barbie's age now and Mary's age now. Did you know that I was born in the same year as Barbie, the doll? I know, we're twins. Okay, so now we can write for this, it's Barbie's age minus 30, Mary's age minus 30. Right, we use these headings to just logically write these expressions that we'll use when we're setting up the problems, all right? Again, some people think, oh, this is a waste. I don't need to draw this chart. Trust me, it's so much easier to write these complicated equations if everything is laid out for you where you can see it. Okay, 30 years ago, Barbie was 1 year older than twice Mary's age then. Okay, so we're comparing Barbie's age 30 years ago, and we're comparing that to Mary's age 30 years ago. The question we ask ourselves is, who was older? Barbie was 1 year older than twice Mary's age. Okay, so if Mary was 2, then Barbie was 5, right? So Barbie's older. So what we have to do to make them the same is we have to multiply Mary times 2 and then add 1. Barbie was 1 year older than twice Mary's age. So Barbie's already older. We need to change Mary to make her older. Multiplying her by 2 is going to definitely make her older. Adding 1 will also make her older. Okay, so we've got the first scenario all set up. Now, what's the other one? 20 years ago, Mary was 4/5 as old as Barbie was. Okay, so let's set up their 20 years ago. Mary was 4/5 as old as Barbie. Okay, so we know that Barbie was older. And we know that multiplying by 4/5 is going to make an age smaller, right? It's not going to make it bigger, it's going to make it smaller. So we want to multiply the bigger number by 4/5. And that will make them the same. So in this problem, we had two different kinds of adjustments. Just remember that multiplying by a fraction less than 1 makes a number smaller. So that's why we chose to do that to the bigger number. All right, there's our system. It's kind of a mess, isn't it? Let's clean up both of our equations. We're going to distribute here and we'll combine those numbers. So we'll have bn minus 30 equals 2mn minus 60 plus 1. Okay, and that we can change to let's do this. Let's put all the numbers over here. And then we'll swim this across. We're getting them into this format is what I'm doing right here. Right, remember we said that when we want to eliminate, this is the format we want. So I'm going to have Brenda's age now. Oh no, Barbie, sorry, we've moved on from Brenda. Minus 2 times Mary's age now is going to equal, let's see, this is minus 60 and plus 31 will be minus 29. Okay. Beautiful. Kind of. It's kind of crazy, right? And now let's clean up this second one. Okay, here we're multiplying by a fraction, so we're going to want to multiply both sides by the denominator. This cancels, and then we have to distribute, and we get 4bn. Here, this is our most up-to-date version of that. 4bn minus 80, there's the mistake I made last time. I'm not going to make it again, equals 5mn, I'll make new mistakes this time, minus 100. There's our distribution, and then we're going to do the same thing. We're going to set this up so that it looks like this. So we'll have 4bn minus 5mn, and then we're going to add 80 to both sides. I'm just doing this in my head rather than writing everything out because we're advanced enough. We can do that. As long as we find we can do it without making mistakes, it's beautiful. 4bn minus 5mn equals negative 20. So here we are. There are our two equations. We could choose to use substitution because here's a variable that doesn't have a coefficient. So we could subtract the 2n, create an expression, and then plug that in for bn. But here's what I'm going to do. I find that most students feel more comfortable with substitution. So I'm going to push on with elimination and see what we can do to work it out that way. So what I'd like to do, if these are our two equations, right? I'm not looking at this one. I would like to multiply our top row by minus 4 so that the bn's will cancel, right? I'm looking at the columns. I don't want to try and cancel those because I'd have to multiply both. If I multiply the top one by minus 4, then they will cancel. I just picked up my marker and threw the cap across the rim. Okay, so I'm going to multiply the top row by minus 4. I will take that to the next page. Okay, So what I'm doing is I'm multiplying minus 4 times the top row. So it's minus 4bn plus 8mn equals, let's see, 4 times 29, it's 80 plus 36. I'm doing 4 times 20 and 4 times 9. It's 80 plus 26, that's 116, and it's positive because the two negatives make a positive. How do you feel about that? I feel good. Okay, and then we have to multiply this by, oh no, we don't have to do anything to this one. It's fine. 4bn minus 5mn equals minus 20. So now what we do is add. These cancel. 3mn equals 96. Divide by 3, divide by 3. Mary's age now equals 32. Fabulous. Now we need to pick an equation and use it to solve for this lady, Barbie. Here, I'm looking at these equations. I like this one. And what I'm going to even do is take this and I'm going to bump that to the other side. So I'm going to go bn equals, it'll be positive 2mn, right? Change sides, change signs. This will stay the same. It's minus 29. Okay, so Barbie's age equals 2 times 32 minus 29. 64 minus 29 equals 35. Right? Because this is almost 30. 34, one more 35. Yay, these are the right answers. That's how old they are. Mary is 32 and Barbie is 35. Barbie and I are a few years more than 35 years old, but it's okay. It's just a problem. Yay! Okay, that is lesson 120. We're really not going to make these age word problems any harder. Like I said, we will come back to them next year and review them, give you another chance to figure out what the heck is going on, but they really won't get any harder. They do show up as classic algebra problems though, so they are definitely worth your drama to solve. Okay, one more lesson. I'll see you tomorrow for lesson 121. Goodbye.